All right. So we are learning polar coordinates today. We're on 6.4. And polar, let's talk about the word polar. Polar reminds you of what word? Huh? North and South Pole. What else? Polarity. I can see you guys are all in chemistry right now. Yes, or like polar bears. But basically, yes, it is the North and South Pole. You remember North and South Pole are the north and south of the whole Earth, right? So actually, when you look at this polar coordinates, it is like the Earth. So in the center, think of it as the North Pole. And you're like an astronaut who is outside of Earth, and you're looking straight down on Earth, and then you're saying, oh, this is the North Pole, and then this is like all your longitudes and latitudes, right, away from the center of the pole, and then, that's the whole Earth in a circle. Does that kind of make sense? So you're looking straight down and looking at this whole Earth like that. So let's learn how to graph polar coordinates. Polar coordinates are in the form of r theta. R means radius, and theta means angle. Okay, theta is Theta. I think I said that before, but just in case you don't know how to read that word, it's theta. It means angle. So what we're going to do is, instead of saying x and y, that's how you have learned coordinates from, kindergarten or something until now. Instead of x and y, it's now r, like how far do you go out from the pole and how much do you turn? Okay, so let's look at this first one. 2 pi over 3. So this point P is 2 pi over 3. That means 2 out from the polar coordinate, and then we're going to turn pi over 3. Okay, so everything starts at the pole. Everything starts at the pole. The pole is 0, 0. So what we're going to do now to get to P is we're going to go 2 out. 2 out, and radius means 2 rings out. So 2 rings out on the 0. We always start at the 0. Okay, 2 rings out. And then we're going to turn pi over 3. Pi over 3, is that positive or negative angle? Positive. So then we need to turn in the positive angle direction. Which direction is positive angle? Show me with your arms. Yes, counterclockwise. So we're going to turn this way, positive pi over 3. So we're on second ring, and we're going to go pi over 3. Okay, so this is where P is. Yes? Okay, so some people have said that they prefer not to do r theta. They do theta and then r. I don't know. So some people find that easier. They find the angle first and then figure out how far. So it's up to you, whichever way is easier for you. Okay, let's try B. We're finding the point Q. Q is -1, 3 pi over 4. -1, 3 pi over 4. -1 means go which direction? Left. Okay, -1 means 1 out, but we're going to go in the negative r direction. So we're here. And then 3 pi over 4. 3 pi over 4. Is that a positive angle or a negative angle? Positive. So where do I turn to go positive angle? We're still going to go counterclockwise from here. So we're going to count 3 pi over 4 from here. Does that make sense? This point, which is 1 out, is now my new 0. And I'm going to count 3 pi over 4 positive. Okay? Please don't just go straight to 3 pi over 4. That's not what it is. Yes?
Can we just go 3 by 4 and just go backwards?
Yes. That's why. So some people said they feel it's easier if you find the angle first and then go radius. So you could go straight to 3 pi over 4, which is on this line, and then say -1 is away from 3 pi over 4. So you could do that as well, whichever one is easiest for you. So here is the point Q. This much is 3 pi over 4 positive. Any questions so far before it gets confusing? Okay. All right, let's have you guys try R. R is 3, negative 45. Let's do this color. So 3, negative 45. So we're going to go 3 out. Negative 45 is this direction. So R is right here. Good? All right. Next one. So let's go ahead and have you graph 3 pi over 3 and label that as P. And we're going to find all the possible ways to write this polar coordinate. So first, label 3 pi over 3 as P, and then we're going to write it as all possible polar coordinates. Okay, 3 pi over 3 is here. Okay, so what we're going to do is we're going to find all the different ways that we can get to this point. So 3 pi over 3. 3 pi over 3. Let's say that I have to keep this radius positive, and I also want to keep this angle positive. What's another way to get to this point? So I went 3 pi over 3. So what's another way to get to this point? 4 pi over 3? Not 4 pi over 3. 4 pi over 3 is going to be here. Negative how much? 5 pi over 3. 5 pi over 3. But let's say that, okay, let's think in the direction of coterminal angles. Remember before when we talk about, let's say 30 degrees, another angle that gets you to 30 degrees is 390, right? So
plus minus 360, general solution.
Oh, right, general solution, so plus minus 360 degrees, or we're in radians, so 2 pi. Okay, so another way to get to the same point is 3, and then we're really just talking about coterminal angles, so just this angle, and then however many times we turn around the circle, 2 pi. And then n just means integer, so however many times we're turning. Okay? Now let's think in another direction. We're going to now go in the negative r first. Okay, we're going negative r first, so we're going negative 3. So we're negative 3 out. How much do I have to move to get to P? And I also want to keep my angle positive. So I am currently here. How do I get back to P? But I want to go in the positive angle direction.
4 pi over 3.
4 pi over 3. Okay, so then I would go this much. 4 pi over 3? Yes? Okay, another way to think of 4 pi over 3 is I travel back pi plus how much the angle was. So I get back to 0. I get back to 0 degrees, and then I travel that much. Does that make sense? Okay, so if I were on the negative r direction, I would say I would have to do the original angle plus pi. Correct? But that's only one solution. What's all the possible solution? What do we do if we want to talk about general solution? Huh? Yeah, 2 pi n. So we plus 2 pi n. Okay, so if you were here on the negative r, so you're right here at this spot, and you want to get to P. You want to get back to P. So you're here and you're trying to get to P. So what you need to do is first travel pi, because you're basically on the opposite side of where 0 is, right? So then you need to travel pi just to get back to where you should be, and then pi over 3. Okay? Okay, from here, we're going to kind of derive the actual formula. So this is going to be this part. I'm going to simplify this part. So what I want to do is just take out the pi from there. So this becomes 1 plus 2n. You guys with me? If I just took this part and then take out the pi, it becomes pi plus 2n. So this becomes negative 3 pi over 3 plus 2n plus 1 pi. Okay, and then this is how you write all the possible polar coordinates to get to that same point. If you have a positive r, you just say that angle plus 2 pi n, because you keep turning around the circle. If you go in the negative r direction, you have to go pi back to go back to where you were, and then that angle, and then plus 2 pi n. Yes? Maybe? Okay, so this is the equation. R, theta plus 2 pi n, and negative r, theta plus 2n plus 1 pi, and that's how you get to all the possible polar coordinates. All right, so let's practice. So if you have this point that you're trying to get to, what are all the possible polar coordinates for P? So again, you have one set for the positive r and one set for the negative r. Okay, go ahead and do that. Okay, this is kind of just a direct application of the formula. So 2 comma pi over 6 plus 2 pi n, negative 2, and then pi over 6 plus 2n plus 1 pi. All right, now what we're going to do is we're going to convert between the polar coordinates, which we just learned, and the xy coordinates, which we've always been doing from up to this point. So let's say that you have this point in space, and we call this xy. If that point is xy, then it must have traveled x amount in the horizontal direction to get to that location, and then it must have went up by y to get to that same location, right? That's how you do xy. X and then y. So that is the 2D coordinate, and we call this coordinate system the rectangular coordinate because it kind of like looks like a rectangle. Whoa. Sorry. Another way to say this is the Cartesian coordinate. Do you guys know that? No idea. Yes, maybe. Okay, Cartesian coordinate comes from that guy, Rene Descartes. He's the person who created the Cartesian coordinate. Right here, next to Euclid. Yes, he's the person who created the Cartesian coordinates. It's a he. I know the name looks like a woman, but it's not. It's Rene Descartes. So he created the Cartesian coordinates, which describes, most of our space, x and y. But that's not how a lot of things in life works, right? Not everything can be described in 2D like that. Sometimes things are easier if you talk about a radius and a turn. So what we're going to do now is we're going to change this xy coordinate into a radius and an angle. So since it has a radius, it must have come from the 0, 0 origin. So this is r. And it has a turn that is the angle. So this is kind of like the vectors, right? We talked about the magnitude and the direction angle. So it's the same idea. So let's think about this. If I know how long x is, if I know how long y is, how do I find r?
Pythagorean.
Yes, Pythagorean theorem. So what you can do is draw a right triangle like this, and then you can see that it's basically x squared plus y squared equals r squared. So that's the first thing you need to remember. X squared plus y squared is equal to r squared. Next, we need to find this angle. This angle here is unknown, but we have two sides, x and y. So x and y makes what trig ratio with that angle?
10.
tangent. You're now going to count 5 seconds before you answer. Thank you. Okay, tangent. So tangent theta is equal to opposite over adjacent. Okay, so this is the relationship between x, y, and r theta, and we're going to use this to convert between rectangular to polar, and then polar back to rectangular. Okay? Okay. Let's think about a few more things. Think back in your vector world just last week. We said, I hope someone remembers, we said, how long is this x part in regards to r and theta? Count 5 seconds. Caleb, you need to think. Don't count for him. How long is x in regards to r and theta?
It's r cosine theta.
Aaron's like, I counted 5 seconds. Yes, that's correct. R cosine theta. So remember back in vector world, we said how long the x part, how long is the x direction? That is magnitude cosine theta. Right? It's the same idea. So then how long is the y direction? Yes, r sine theta. All right. We have everything we need. We are now going to translate or change between polar and rectangular. So convert the following polar coordinates into rectangular coordinates. So this is r theta. We need to change it into xy. We just figured out that x just means r cosine. Y means r sine. Okay, so this is a very, very easy question. It's just an application. If you remember the formula, it's just applying the formula. 3 cosine 5 pi over 6 and 3 sine 5 pi over 6. Since 5 pi over 6 is in the unit circle, let's just think about what the numbers should be. 3 and then cosine. Cosine 5 pi over 6. Cosine 5 pi over 6 is what? Negative square root 3 over 2. Negative square root 3 over 2. Okay, and then sine 5 pi over 6. 1 over 2. Yes. Okay, so that tells me I should be at negative 3 root 3 over 2 and 3/2. Okay, let's kind of think about it a little bit. 3, 5 pi over 6. I'm right here. Am I going to get to the same point if I just go negative 3 root 3 over 2 and 3/2? Kind of looks like it. So we can get to the same point with two different kinds of coordinate system. Yes. Okay. All right, let's have you try one. Q. Change this polar coordinate into xy coordinate. Okay, this is just applying the formula. So negative 1.88, comma 0.68. All right, we're now going to go backwards. Given a rectangular coordinate, so this is an xy. So make sure you read the question or else you might be confused what they are giving you. You want to find two polar coordinates pairs. Two polar coordinate pairs. All right, the first thing you want to do is just try to figure out where your point is. Negative 1, negative 1. That's here. We want to rewrite this point as a polar coordinate. That means we need a radius and we need an angle. The angle is from 0 degrees. Okay, I think I'm going to let you guys take this one because it's just like the vectors, trying to figure out the magnitude and try to figure out the direction angle. So find r, find theta, and then let me check it. So go ahead and talk to your partner, find r. How long is this? And what is the angle from 0 degrees? Okay, r is going to be the length of this part, right? So this is going to be a right triangle like this, and this is 1, this is 1, this has to be square root 2, so this is square root 2. Since it's an isosceles, this has to be a 45 degrees. But remember your direction angle is all the way from 0 degrees. So this must be 225. Okay, so one pair of polar coordinate would be square root 2, 225. That's one. The other one, if you want to write it in terms of negative square root 2, if you go negative square root 2 already, how much do you have to turn to get to that point? 45 degrees, because you're pretty much there. Okay, so 45 degrees. If you go into positive r, you would have to turn all the way to 225. But if you go negative r, you're almost exactly there, only 45. Okay, let's have you try another one. Negative 3, 0. This one's pretty easy because you're on the axis. Okay, so find two polar coordinate pairs. Okay, so 3 pi, or some of you wrote 3 180, it's the same. And then negative 3 0, or negative 3 0 degrees. 0 radian, 0 degrees are the same. All right, we just learned how to change from polar coordinate to rectangular coordinates and back and forth. We only change one point. Now what we're going to do is we're going to change the entire equation from polar equations to rectangular equation and rectangular equation back. Okay, so we're going to convert first from polar equation into rectangular form. All right, we have this equation r equals 4 cosine theta. Let's go ahead and graph it first to see what shape we're supposed to see. So yesterday we learned how to change our calculator into the parametric mode. We're going to now go in and change it to polar mode. So if you go into mode, instead of parametric, we're going to go to POL. POL means polar. Okay, if you do that, then when you go to y equals, it should just be in R1. Radius equals something something theta. And then if you press the variable button, it should just automatically give you an angle. Okay, so we're going to first graph 4 cosine theta. And please also make sure that your mode is in radian and not in degrees. If you're in degrees, then you're not actually going to see the entire graph. So if you only see like a dot or like a straight line, then you're in degrees mode. Okay, so graph it. And what you want to do is actually, your calculator is rectangle, right? So it's not going to graph a very nice graph. So what you want to do is make sure your calculator is graphing exactly the right interval. So what I do is I go to zoom 4, and then it will graph a perfectly nice shape for me. Okay, zoom 4. I think I'm in. Okay, what shape is this? Circles, yeah. So this is a circle. So we're going to change this equation into rectangular form. We better see a circle equation. So we're going to take this equation. R equals 4 cosine theta. And we're going to try to utilize all the conversion stuff that we had learned. So the conversion stuff we had was x equals r cosine. Y equals r sine. X squared plus y squared equals r squared. We're going to use those 3 equations and go back and forth somehow to change this entire thing to only have x and y and no r theta. I see that I have a cosine theta. And I remember that there's a r cosine theta equal to x, but there's no r. So that's kind of a problem. So what I want to do now is I'm going to multiply everything by r so that I can change it over to x. Does that make sense? So I see this cosine. That reminds me of r cosine theta, except there's no r. So I'm going to multiply everything by r so that I can change this over. So this is r squared equals 4r cosine theta. R squared is what in terms of x and y? Yeah. X squared plus y squared. And then our cosine is what? Okay, that part is x, so this is 4x. So this equation really becomes x squared plus y squared equals 4x. So at this time, I have pretty much successfully moved everything over. There is no r theta. There is only xy. But I do want to continue. I want to see that this is really a circle equation. So what I want to do is complete the square. So I'm going to move the 4x over. And I know I'm going to complete the square, so I'm going to add a number here. Yes, and then I'm going to add a number on the right as well to keep it balanced. Huh? Yeah, so 4 goes inside both boxes. Remember, when you complete the square, whatever you add to one side, you got to add to the other side.
Why is r squared x squared plus y squared?
So remember this.
Oh yeah, no.
Okay, now I'm going to factor and simplify. So this is x minus 2 squared plus y squared equals 4. That looks like a circle equation. Where is the center of the circle? 2, 0. And then where's the radius? Or how long is the radius? 2. All right, now let's look at the graph and you check. Is the center of my graph at 2, 0? Yes. Is the radius 2? Yes. Then I did it right. So, yes.
How do you get 4 again? Is it b?
B over 2 squared.
2 squared?
Yeah. Okay, we're a little short on time, so I'm going to show you just one more. How to change from rectangular into polar. Okay. Changing from here into polar is a little hard. So what I want to do now is expand this into a big polynomial. So x minus 3 squared is going to be x squared minus 6x plus 9. Y minus 2 squared is y squared minus 4y plus 4 equals 13. Remember, I'm changing everything into r and theta, so all this x and y has to go. I know that x squared plus y squared is going to give me the r squared, so I'm going to move it together. And then I just leave everything here. 9 plus 4 is 13, and that's going to cancel my 13 on the other side. Okay, I'm going to change it over. X squared plus y squared is r squared minus 6. What's x? R cosine theta. And then minus 4, and then y is r sine theta. The 13 and the 13 are going to cancel, so it's equal to 0. The last thing I'm going to do is I look at it and then say, what are the repeating factors of these 3 terms? R. So I'm going to take r out. So it's r minus 6 cosine theta minus 4 sine theta equals 0. If I make each part equal to 0, r is 0, and then r minus 6 cosine theta minus 4 sine theta is 0. Remember, I'm trying to write a polar equation, so it has to be r in terms of theta. So r equals 6 cosine theta plus 4 sine theta. This is the answer. R equals 0 is the dot. It's an answer that makes no good information. So if you graph that one, it would be the same shape as the one we had in the beginning, which was another circle. So if you graph this one in your calculator, you should get another circle. All right, we'll come back tomorrow and finish some more.